Hello, in this video we're going to be talking about infinity, limits, and asymptotes. Specifically, when a limit spits out infinity, what happens with the asymptotes. So, quick reminder about limits. You need to make sure for a limit to exist, both the left hand and the right hand limits have to agree with each other. If they don't agree with each other, then you do not have a limit. Now, this is specifically important because most limits that spit out infinity don't actually exist. They're usually just a limit on one side or the other. There are some cases where they are heading towards infinity together, and that limit would exist. However, most of our limits with infinity are either just a left hand or a right hand limit. Now, if we have one of those left or right hand limits, we get a vertical asymptote. And that asymptote is where what value we put into our limit that caused the infinity to show up in the first place. Important thing to note about this is saying that the function grows without bound, that is constantly growing and growing and growing. These are non-removable discontinuities, so even though there's just that single point where we have a problem, even if they're both heading towards that same thing, we can't just fill in a point to remove the discontinuity. And also, everything I set up above, that works the same way as if x is approaching c from the left instead of the right. Infinity or negative infinity as x approaches negative 2 from the left or from the right. So as we come in down here, we can see that we're heading down towards negative infinity. We have that big vertical asymptote. As we come in from the right, we're heading towards positive infinity. So as x approaches negative 2 from the left, we can see that it is heading down towards negative infinity. And as x approaches negative 2 from the right, we're heading up towards positive infinity. You can also kind of spot this as we are dividing and we're not able to cancel that thing out. That often causes these infinite limits to exist. We want to try to determine what are the vertical asymptotes of this graph. Now, based on all the gobbledygook that we have right here, I can't really tell. So your best bet is to factor that stuff. And I've got it hidden here. There we go. So I factor my doodads. And if you look at what we've got, these x minus 2's are able to cancel each other out. Since they are able to cancel each other out, they are a removable discontinuity. And these limits that spit out infinity are not removable. So that's not going to be an infinite limit. However, this 2x minus 1, that one doesn't cancel out. All I've got is that x plus 2 up top. So that makes our asymptote to be at x equals 1/2. That was a terrible circle. You can try to see it in the graph. It's why this algebraic stuff is important. I can see it somewhere around here, but I don't really know for sure. And I could sit and zoom, but then I won't be able to really tell the detail of that 1/2. It's why this algebraic skill of identifying it is important. You can also see the removable discontinuity there at 2. Something to note in these two examples is, as I was saying, the things that aren't able to cancel are the things that aren't able to create vertical asymptotes. So that x minus 2, that's not able to cancel, that x plus 2, that's not able to cancel, and they're each creating a vertical asymptote. Over here, yes, this is not able to cancel out. However, it doesn't have any real zeros. There is no number I can put in for x squared here in order to get this thing to equal 0. So since there is no technical problem with that, we have no actual asymptotes to worry about. So yes, we're concerned about things that don't cancel, but even though this didn't cancel, we need to make sure they actually equal 0 somehow. Now, in these examples, we're trying to actually evaluate one of those one-sided limits and determine if it's going to be positive or negative infinity. I can look at this and say, yeah, that is not going to cancel. And I can look at this graph and I can say, yeah, as I'm coming in from the right, it's heading towards positive infinity. But what if this is a non-calculator problem? How am I supposed to figure out whether it's going to be positive infinity or negative infinity based on the information I'm given? Well, you want to kind of think about this, is what is happening as we're getting close to negative 1 coming in from the right. So as we're approaching negative 1 from the right, whatever this value is, it's going to get really, really, really small, but it's definitely going to be positive. So think if you put like negative 1/2 in there, or negative 3/4 in there, or negative 9/10 in there. Whatever I'm putting in there is going to be smaller than 1. So this piece right here is going to stay positive. So as I'm getting close to this is starting to blow up. And so it's starting to become that infinity thing. But the way it's starting to become that infinity thing is being positive. So this thing is heading towards positive infinity. If we did that same thing from the other side, we're putting in like -2, -1/2, -1.5, then it is starting to blow up. But it's blowing up, and all those values that we're putting it into there are being positive. So it's heading towards, in this case, down towards negative infinity down here. Now, over in this one, same deal. What is happening as x is approaching 0 from the right? What is happening to my sine value? So as I'm plugging in values in quadrant 1 of our trig stuff, plugging in those values for sine, we got positive, we got positive, we got positive, we got positive, until we hit 0, where sine is 0 and everything blows up. So it's positive, 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 positive. Oh, okay, so this thing is heading towards positive infinity. So woof. If we were coming in from the left-hand side and we're down in quadrants 3 and 4, it's negatives, 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 negatives. Oh, it blows up. So it's been negatives for a while. It's probably heading towards negative infinity. If this had been a -2, oh man, this would have been positive, 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 positive. And then, oh no, this 2 on the top made everything negative. So it might switch around. So look at what's happening with other stuff in your problem. And that's it for limits that spit out infinity and are vertical asymptotes. So if your function is spitting out infinity, note that it is giving you a vertical asymptote. And most importantly, remember that these, even if the limit does exist and it is both heading towards infinity, it is not a removable discontinuity, even though it's just a single point where a discontinuity happens. Thanks for watching. Bye-bye.